History remembers the headlines, we find the bylines. This is the Unsung. In 1969, a young black man from rural Illinois walked into a PhD program that had never admitted anyone like him. The University of Illinois at Urbana-Champaign's computer science department didn't quite know what to do with him. While others walked with an air of belonging, he walked against a current of unfamiliar faces, a solitary figure in a sea of white students, carrying the weight of expectation and the spark of untapped genius. This man was Clarence Ellis, known to his friends as Skip, and he was about to become the first African American to earn a PhD in computer science. His journey, however, started long before those university halls, in a place where opportunities were scarce and dreams were often deferred. Clarence Ellis grew up in the heavily segregated town of Cairo, Illinois, a place etched with racial divides. His family was poor, and the future seemed to offer very few paths. His first encounter with a computer wasn't in a gleaming lab, but at a local community college that almost didn't accept him. There, he met a hulking IBM card punch machine. While others saw a complicated piece of equipment, Ellis saw a world of possibility. The college didn't have instructors for it, just a stack of manuals. So night after night, Ellis would lock himself in the computer room, teaching himself the machine's language, punching cards, and reading manuals by the machine's faint glow. He later called this time his playpen, a space where he could experiment and learn without limits. This relentless curiosity and self-driven education would become the hallmark of his entire career. After earning his historic PhD, Ellis's path led him to one of the most innovative places on Earth in the 1970s, Xerox PARC, the Palo Alto Research Center. This was the legendary think tank that gave birth to the modern personal computer, the laser printer, and Ethernet. When people think of PARC, they often think of Steve Jobs' famous visit, the Alto computer, and the invention of the mouse. But Skip Ellis wasn't working on the shiny objects. He was working on something far more fundamental, something invisible, the connective tissue that would allow people to work together through computers. While his colleagues were building the machine, Ellis was building the community inside the machine. He led the development of a system called OfficeTalk. Imagine this, it's the 1970s. The internet is a fledgling academic network. And yet, in this lab, Ellis and his team were creating one of the very first systems that allowed multiple people to see and edit the same document, at the same time from different computers. This was the birth of collaborative computing, decades before Google Docs or Microsoft 365 made it a daily reality for billions. He was envisioning a future where computers weren't just for individual tasks, but for shared creation. He was building the digital office, the virtual meeting room, before most people even had a computer in their home. Ellis had a guiding philosophy he called making the invisible visible. He believed that computers were tools for humans, not the other way around. They shouldn't force us to learn their complex, rigid languages. Instead, they should adapt to our intuition, to the way we naturally think and act. This simple but revolutionary idea was at the heart of his work. It's what drove him to pioneer what we now call the Graphical User Interface, or GUI. He and his team at PARC were obsessed with the question, how do you make this powerful new technology feel simple? How do you create an action that feels so natural it becomes second nature? The answer they found was elegant, simple, and profound. A single click could select an object. But what if you wanted to open it, to execute a command? You could use a menu, sure, but that was slow. The solution was the double click. A quick, deliberate gesture that says, I don't just want to point at this. I want to do something with it. The double click wasn't just a technical fix for a programming problem. It was an act of empathy, a translation of human intent into digital action. It was one of the first crucial steps in making computers accessible to everyone, not just programmers and engineers. This small, seemingly insignificant gesture helped to democratize the digital world. Today, billions of people around the globe double-click every single day without a second thought. It's a universal digital reflex. We double-click to open our files, launch our favorite apps, and start our work. It's a fundamental part of our interaction with technology. Yet, the name Clarence "Skip" Ellis appears almost nowhere in the standard popular history of Silicon Valley. His contributions, like the collaborative systems he built, have remained largely invisible, absorbed into the fabric of the technology we take for granted. Why? Perhaps it's because Ellis wasn't a showman. He wasn't a celebrity CEO or a self-promoting visionary. He was a quiet, dedicated scientist, a teacher, and a mentor. He didn't seek credit. He sought solutions. He wasn't interested in building a brand. He was interested in building a better, more humane way for people to interact with machines. He spent the later part of his career in academia and as the first African-American fellow at IBM, continuing to push the boundaries of collaborative systems and mentoring the next generation of computer scientists. In 2011, his peers finally gave him one of the highest honors in his field, the ACM SIGCHI Lifetime Achievement Award, recognizing his foundational work in human-computer interaction. He passed away in 2014, leaving behind a legacy that is both monumental and quiet. The story of Skip Ellis isn't just about forgotten history. It's a reminder that true innovation often happens in the background, in the quiet, painstaking work of making complex things simple. It's in the foundational architecture that no one sees but everyone relies on. Clarence Ellis proved that the most profound invention isn't always the flashy machine itself. Sometimes it's the simple, intuitive gesture that makes the machine feel like a seamless extension of yourself. He didn't just write code. He wrote a new chapter in how humanity communicates. Thanks for watching. Subscribe to the Unsung for more stories they left out of the timeline.